Hello, my dear students. Welcome back to the lecture. So here we'll try to find the this thing, which is that, yeah, crank distributor bar. Okay. So first, again, I've written crank distributor bar along the shorter span. That is both the side I'll do. Okay. This crank length I'll find now. Crank distributor. This side. Maybe usually practically 4 to 5 bars will come on this side and 5 bars will come on this side. Okay. I'm telling 4 to 5. Depends what is the size that you have. Okay, chalo, fine. So first you find the cutting length. How you will find the cutting length of this? So this is 7 meter plus 230 from here, 230 from here, minus one cover from here, minus one cover from here. The same thing you're done. Okay, yeah. So 230 plus 7,000 plus 230 minus 25 minus 25. Simple, fine. So now again crank distributor, number of member is 1, dia is 10 diameter, and spacing is 150. Again, you'll ask me, sir, where it is mentioned. See, all the things will not be mentioned in the slab drawing. In the footing, column, beam, they mention. In the slab, usually they mention shorter span bar and longer span bar. Crank distributor and top extra bar, they don't mention anything. It is what we practice on the side. So usually remember, your crank distributor diameter and the spacing will be similar to your longer direction bar. This is your longer direction bar, isn't it? If you're putting your crank distributor like this, so take whatever diameter you have put in the longer span bar. It's a 10 die 150. A crank distributor also will be 10 die at 150. If you're putting along the shorter span, whatever main reinforcement you have provided along the shorter span, that is 10 die at 150, this also will be 10 die at 150. Similarly, your top extra bar, whatever main reinforcement you have provided, it's a 10 die at 150. That spacing you have to double. If it is 150, your top extra will be at 300 center to center spacing, because whatever number of bar you get in the main reinforcement, that much amount of top extra is going to come. All right. So if your main bar, that is, for example, if you don't understand, see, what is the main reinforcement I got? 25 plus 24 is 49 number of main reinforcement I got. So when I calculate the top extra, no, top extra also will be 49 only. Getting my point? Okay. I mean, in case of two-way slab, it won't be 49. Because crank distribution, in case of one-way slab, it will be 49. I'll prove you that also. See how much it was? 26 number of bar you had got main reinforcement, and see your top extra. Your top extra also should be 26 only. Of course, 28 we got. The reason was we added plus one there, both that side. But usually, and since it's a round of what we have done, but actually it is 26 only, because it cannot be 28. If this is 28, this also will be 28 then. Okay. Similarly, your distribution still anyhow, it's a one-way slab. You don't put top extra here. So this will be actually 26. Okay. So if you ask me how many top, yeah, see, this is top extra. Wherever your bottom that bar has gone, no, there only your top extra will come. So don't be under the impression that your top extra bar will be more. No, whatever main reinforcement will come, that much only top extra is going to come. Okay. Fine. So this is done. This is done. This is done. Yeah. Okay. Fine. Now come here. So spacing is 150. That you have to assume it is to be 150. So number of bar. So 5 meter I have to take. So your this is 5 meter, but L by 4, 5,000 divided by 4 is 1250. So 1250 divided by spacing of crank distributor is 200, and plus 1 I'll do. So I'll get 10 number of bar. Since on both the side I have to put crank distributor on this side and crank distributor on this side. So I'll multiply this value by 2. Okay. So 20 number of bar I'll get. So cutting length will be 7410. This is 7.41. Total cutting length will be 7.41 into 20 number of bar into number of member is 1. So it is 148.2 kg of a steel is required. Since it's a 10 diameter bar, 148.2 into 0.617 will be 91.43 kg. Simple. So crank distributor along the shorter I found. Now along the longer also you have to find, because it's a two-way slab. So again, now I'll find crank distributor on this side. Similarly on this side. Okay. So tell me what is the cutting length of this? Same. 230 plus this 5 meter plus 230 minus 1 cover from here, minus 1 cover from here. Okay. Same thing I've done it here. 230 plus 5,000 plus 230 minus 25 from here, minus 25 from here. Okay. So crank distributor bar along the longest span on both the side. So again, this is also number of member is 1. dia is 10, spacing is again 150 because your distribution bar also was 10 at 150. This also is 150. Sometimes they may tell you the crank distribution spacing. In that case, whatever is given, that you have to take. But right now there is nothing mentioned, so this is what we practice. Now come to the number of bar. So number of bar, I have to take opposite direction. That is 7000 divided by 4 is 1750. So 1750 divide by 150 plus 1 comma 0 and multiply by 2. So 26 number of bar is required. That means 13 crank bar will come here and 13 crank distributor will come here. Got it? Fine. So cutting length will be 5410. So this is 5.41 and this total will be 5.41 into 26 into 1. This will be 140.66, and since it's a 10 diameter bar, 140.66 into 0.617 will be 86.78 kg of a steel is required. So 90% of my BBS is ready. Last one portion is left out. That is top extra bar. Now come to the top extra bar. Okay. So next is top extra bar. So again, how you'll find the top extra bar? Simple. Yeah, tell me where your top extra will come. Your top extra is gonna come only in this portion. That is L by 2 portion. Your top extra will come. Yeah, only in this portion your top extra will come. Similarly, here your top extra will come. Okay, in this portion only top extra will come. Whereas this side and this side already your crank distributor you have put. Right? Remember, just now we calculated crank distributor. So already your crank distributor is going here. So that is why your top extra is not required here again. Unnecessary, you are increasing the steel by putting that. Okay, fine. First, what we'll do, we'll find the cutting length of this top extra. So the cutting length will be how much? So this is L by 4. From here to here, it is L by 4. So 5000 divided by 4 is 1250. Plus 230 is the width of your beam. Minus 1 cover. So 1250 plus 230 minus 25. So I got the cutting length. So top extra bar along the shorter span, I am putting this on both the side. 1. Dia is again 10. Spacing I have written 300. Why? Your main reinforcement was at 150. So 150 double of 150 is 300. So I am writing 300 here. Okay. 300. So now come to the number of bar. So number of bar what I have taken 3500. Why? This length is 7000, but crank will be put only in this portion. It's a two-way slab, so it will be L by 2. 7000 divided by 2 is 3500. So in the 3500 region only a crank will be put. So 3500 divided by 300. You'll not do plus 1. Why? Because in the crank distribution already the plus 1 has been done. Here again if you do plus 1, you are unnecessarily increasing the number of bar, which on practically that much number of bar will not come. Okay. So 3500 divided by 300, bracket close, comma, and I'll multiply this by 2 because 1, 2, 3, 4 this side and also this side. Both the side I have done it. So that is why I multiplied by 2. So I'll get 24 number of bar. Suppose if you don't want to multiply by 2, in that case, what you're supposed to do? In that case, you have to keep spacing 150. You'll get the same answer. See, you got 24, right? If you do the spacing 150, then you'll get 24. Else you keep spacing 300 and this you multiply by 2 because both the side it will take, then also you'll get 24. So this is the right way of doing, because so that practical on the side also you are placing the top extra by 300. Okay. So cutting length is 1455. Cutting length in meter is 1.455. Total cutting length will be 1.455 into 24 number of bar into 1, 34.92, and total weight will be 34.92 into 0.617 will be 21.54 kg of a steel is required. So along the shorter span is done. Now do along the longer span. Now along the longer span, your crank distributor will be put only up to here like this. This is your L by 2. Similarly, this is L by 2. And the remaining portion what you have here, already you have put a crank distributor, so you don't require top extra. Crank distributor is already put, which you already calculated, so you don't require top extra here. Okay, fine. So this cutting length again, this is 7000. So this will be crank distributor will be L by 4. So 7000 divided by 4 is will be 1750 plus 230 minus 25. So it will be 1955. So top extra bar along the longer span, that is both side. Again, it's a number of member is 1, dia is 10, spacing, we are increasing the spacing. Main bar, your longer span, main bar is actually 150. So here it is 300. Suppose if your longer span bar, that is this bar, suppose instead of 150, suppose here 10 die at 150 is given, so top extra will be double of this. 150 into 2 is 300. Suppose if it was given 200, your top extra would be at 400. In that case, on the Excel sheet, you would have put 400. But here it is 150, so I'm putting 300 here. Got it, no? So whatever is your main reinforcement, double of that will be a top extra. So 300. So number of bar again, since it is L by 2, 5000 divided by 2 is 2500. So this span from here to here is 2500 divided by 300. Again, no plus 1 because already this crank distributor plus 1 you are done. So again, you don't have to do here. So if you do, what will happen? Nothing will happen. Yeah, just the steel will increase, which you practically don't do that. Practically, that much space you'll not be having. Plus 1 you're doing 2-3 times. That much bar will not, it cannot accommodate. Okay, but if you do nothing wrong, okay, fine. 1.955 and total cutting length will be 1.955 into 18 number of bar into 1 if you do, it will be 35.19. Since it's a 10 diameter bar, 35.19 into 0.617 will be 21.712 kg of a steel is required. So in this way, my entire two-way slab BBS is ready. Now, if you ask me, sir, how much steel is required here? I calculated everything. 21 plus 21 plus 86, 91, 77, add everything, all the 10 diameter bar. So you require 546.113 kg of steel is required in this two-way slab. So in this way, I've done the BBS for this particular slab. If somebody asks you tomorrow, say I want to do only one slab is there, let us consider, and I want to do the BBS for this, tell me how much steel is required. So you did a BBS, you told you got 546. You say roughly we bring 600 kg of a steel, let's say 0.6 ton of steel if you bring, I think that is sufficient for you to prepare the slab reinforcement. So that is why the BBS are to be done. Now practically, do you think exactly 546.113 of steel will go? No. Another some, let us say 20-30 kg extra may come because site we don't know what is the actual measurement, what has happened on the site. Your slab may not be exactly 5 meters, it may be 5.1 or 5.2. Okay, because these are concrete structures, so they are prone to expand and contract, shrink and all. And your reinforcement, whatever centering you're done, whatever shuttering you're done, they're prone to either expand or sometimes contract. So that is why exactly 5 meter you don't get on the site. And do you think all the bar bender will keep this bar at 300 center to center spacing? That also practically doesn't happen. Do you think practically on the side, if you take a tape and if you measure, this will be exactly 300? Nothing. There may be 290 also. So if you do 290, 295 times, there is an error of 50 where it can accommodate one more extra bar, right? So all this bar 150, 150, you don't find it. But if there is a proper strict quality control and all, you can try to play with all these things and you can minimize those extra bar which will go into this. So that is why checking is very important on the site. If you do proper checking, if you check exactly at 150 you're placing, then exactly your answer will match to what calculation you have done it here. But if one or two bar extra goes, that doesn't matter. Okay, no problem. Less should not happen. More if it goes, it's okay. Too much more also not good. Less should not happen. Instead of 18, if 19 bar goes, it's okay. But instead of 18, 17 bar should not go. Instead of 18, 16 bar should not come. 18 minimum I require. 19 if it comes, well and good. But 25 should not come. That means unnecessary increasing the steel there. Okay, fine. So in the next lecture, I'll go with again same calculation. Next lecture also, I'll start with one-way slab. Okay. Again, your length is also 5 meter. This is 7 meter. Now again, I won't explain to the level what I've explained. Directly, I'll show you the Excel sheets and I keep on explaining you. Okay, that's it. So this is again second panel and this is sunken portion. 3 panels I have done. Excel sheet is ready. This panel, and answer remains the same. Whatever answer you get here, if you multiply by 3, 1, 2, 3, directly 3 answers you are gonna get. But we have to break it down separately and we have to do the calculation. So try to prepare the Excel sheets up to here. We'll see you back in the next lecture. Thank you.